perforation, otherwise you cannot communicate with the person because you have case and cement. So in that case, we have to use perforation. Okay, thank you. I'm again keeping you in mute.
Thank you, sir.
So this is how we are going to conduct the lecture. So it will give you a little bit hint also. So this perforation you have already studied, and this is a casing, then cement sheet is surrounding the casing. You have to penetrate through casing, cementing, and into the formation. And these are the some terminology you should know about. So this one is crust zone diameter, and this one is perforation diameter. So it will give you the idea that surrounding the perforation, you will have crust zone, which is basically kind of damaged zone. And so we'll discuss about that also in subsequent slide. This is known as perforation length, this portion from cement to end of perforation. And the angle between these two perforation is known as phase angle. If it is 180 degree, then one perforation is suppose in north direction, another one will be in south direction. The angle between two perforations are 180. So you will have two perforations in basically one circle, you can say. If it is 120 degree, then you will have three perforations basically at 120 degree angle apart. And this is known as perforation spacing, the distance between the two perforations, and that depend on shot density. The unit of perforation density is shots per foot. So how many perforations are present per foot? That is SPF generally we are using. And this one is the entrance hole diameter in casing. And the exit at the end, the diameter will be slightly less than entrance hole diameter. That also you will see in the diagram in subsequent slide. This is all about perforation. One more important part is you can see that this is a damaged zone diameter. This is a damage caused by drilling activities. So while you drill, you will have some damaged zone and you have to penetrate, means depth of penetration or perforation length should be higher than the radius of this damaged zone. Means you should go beyond this point if you want to have a higher production. So that's what it means. There are various alternatives, like you can select different types of gun that already you have studied, different charge types. You can select shots per foot, then shot phasing, gun positions, degree of under or overbalance pressure at the time of perforation, that also we'll study in the subsequent slide. So since the perforating is typically the sole means of establishing communication with the reservoir, it is critically important that this aspect of the completion receive the proper engineering focus, because this is the only way that you communicate with formation. So this is the way, this is a communication channel between the well and formation. So it is very important to decide the type of perforations, number of perforations, what kind of charges that you are going to use, what kind of gun that we have to select, and that also depends of type of formation, formation fluid, and permeability of formation. So many parameters that affect the perforation. So it is very, and it is also the critical parameter because it only provides the channel for production. And if you want to drill the well for injection, so through this perforation only you are able to inject the water. So for production well, development or injection well, it is very important to decide the perforations, and they are going to remain in the well throughout the life of the well. So we have to see that in future, if you want to carry out any treatments like hydrofracturing treatment, uh, matrix acidization or acid fracturing, or any type of treatments, that also will be through this perforation. So this perforation should not be a limitation for that, but for the treatments that you will carry out after certain period of time, like 5 years, 10 years, or 15 years. So depending on the type of formation, if you are planning to go for certain treatments, then you have to decide the perforation accordingly. Otherwise you will not get the effectiveness of that treatments, because this perforation will provide the limitations for. Now we'll discuss about the shape chart perforator. So the process of liner and collapse, liner collapse. So this is liner and the jet will be formed. So the process of liner collapse and jet formation begin with detonating the base of the chart. So before that, let us see that this is a simple shape chart perforator. It will have three major components. One is the detonator, this is explosive or charge, and this is liner. So the type of explosive, the shape of the liner and detonator will be responsible for the type of perforation that you will get. So this also I think you have studied a little bit. A detonation wave sweeps through the explosive, chemically releasing the energy. So this part will be ignited. And high pressure gases at the detonation front measure approximately 3 to 5 million psi and impart momentum, forcing the liner to collapse on itself along an axis of symmetry. So this liner will collapse and this jet will penetrate through cement and casing. And for that also we have subsequent slide where we will see that how this jet will be deformed. Jet will be formed and this liner is collapsed, and how the jet is formed and how it is penetrating through the casing and cementing. So different collapse and penetration characteristics will result depending on the shape and material of the liner. That is what already we have discussed. Now this is important part. If you have conical shape of liner, in that case you will get long and thin stretching jet which will develop the deep penetration with small diameter hole. So when you want deep penetration with small diameter, then the shape of this liner should be conical. And when you select parabolic or hemispherical shape of this liner, then much more massive and slower moving jet will be developed, and you will get shallow penetration but with relatively large hole diameter. So when you have parabolic and hemispherical shape liner, then you will get shallow penetration with large diameter of perforation. So the liner design, as we have discussed, it is a tremendous influence. It has tremendous influence on the perforation characteristics of a shaped charge. And according to its shape, you can have two different perforators. You can classify them as a deep perforating DP or big hole BH. So the deep penetrating, sorry, it's not deep perforating, it's deep penetrating DP. It is for deep penetration, and the diameter you will get is between 0.2 to 0.5 inch, and with penetration depth in concrete of up to several dozen inches. So this is from the laboratory experiment when they had concrete, and when you use deep penetration charges, deep penetrating perforator, then you will get 0.2 to 0.5 inch diameter. But the depth also depends on the type of formation, the mechanical strength of formation, then stress, how the stresses are present in the formation, forward and pressure. Everything will uh, affect the depth of penetration. And they are generally used for perforating the hard formations. So when you have soft formations, we generally use the big hole charges that we'll discuss later. But before that, let us see that deep penetrating sequence. So this is a conical liner, this is a carrier and fluid gap casing. Then it should be cement around it and thereafter formation. So when you detonate the uh, charges, the liner is going to collapse in this way when you have conical liner, and thereafter later stages of liner collapse, it produces slower moving slug. So you can see that slower moving slug is developed when the later stages of liner, when it is collapsing, and then slug is develops into jet, and it you can see that jet is penetrating through the carrier. So first this jet penetrates through carrier, then it will enter into this fluid portion, and thereafter you can see here it will penetrate casing and cementing, and it will enter into the formation. And you can see that diameter is very small, and depth of penetration you will get will be higher in case of deep penetrating sequence. Now big hole charges, they are designed with hole diameters of between 0.6 and 1.5 inch to facilitate placement of sand or proppant, and penetrations are normally 8 inch or less. Now in this case, as we have discussed, the shape will be parabolic or hemispherical, and diameter is more 0.6 to 1.5 inch, and depth of penetration is quite less. It's around 8 inch. And BH charges are generally used for perforating unconsolidated formations that require some form of sand control. So generally for unconsolidated formations, we use BH charges. And this is the BH charge sequence. You can see the shape of liner, it is parabolic. The rest of the things are similar. Now you can see the liner collapse. Now you can differentiate this with the DP charges. So it's quite different shape, and that's how you get very slow moving jet. And here the material is concentrated here. Then the slow moving jet will penetrate first through carrier, then it is going to penetrate through casing and cementing. And here you can see the large hole in the casing is developed and very small hole in the carrier. So in the carrier the hole is very small, but it will create the very large hole in the casing. Now if you want to compare this with the DP, then you can see this figure. I'm just pulling you this slide. So you can see the difference here. Here the difference is how the liner is collapsed in the, this was the conical shape, that was the parabolic shape, and this is how the jet is developed. And here you can see that this is a little bit bigger diameter as compared to the diameter at the casing. Okay, so it is very important to optimizing the chart performance, and but it is not easy task, because it depends on the physics of liner collapse and target penetration, and it is extreme dynamic conditions which exist during the collapse and penetration, and which involve the calculation concerning the elasticity, plasticity, hydrodynamics, fracture mechanics, and material characterization. So you can see that so many parameters are affecting the performance of perforator. So it is very dynamic condition. So this is all about the shaped charge perforator. Do you have any query? So Suraj has some query. Let me unmute him.
Hello, sir.
Yes, sir. Go ahead.
Sir, in deep penetrating, the diameter of casing will be smaller than the diameter of the carrier, right?
Yes. Means
And
it looks similar,
okay.
but if you
And
consider
for
pH, then diameter of carrier means when it penetrates, diameter of carrier is quite small as compared to the diameter it generates at casing.
big hole, the diameter of carrier will be smaller than the diameter of casing.
It's not diameter of carrier. Basically, the diameter it is developed or it is created when the jet is developed. Means when we are
Yeah, means that
perforating,
hole.
the hole which is created in the
Yeah.
carrier is quite small as compared to the hole which is created in the casing. So the perforation
Okay.
diameter will be quite higher than
Okay.
the diameter which is generated in carrier.
Okay, sir.
And Porania has also some query. Okay, Parag, go ahead.
Sir, do the type of completion fluid that is already present in the well affects our shaped charge or perforation?
See, generally the type of completion fluid, it should not affect much as per my information. Because generally we use some brine,
Yes.
so it should not affect much. The important parameters are the formation type, what kind of permeability the formation is having, what is the mechanical strength, whether it is a brittle structure of formation, and important one is the shape of this shape of this liner, and what kind of charges that we are using. They are going to affect the perforation.
Sir, I have one question regarding this.
Yeah, please go ahead.
Sir, if the density of that compression fluid is high, then won't it resist the velocity of the jet?
Yeah, I agree with you. It will resist, but as compared to other parameters, it is not it will not be much significant.
Okay, sir.
I'm not denying that it is not going to affect. It will affect, but other parameters are more important when we are selecting
Okay, sir.
parameter. Okay.
Okay, sir. Thank you.
Okay, thank you.
So any other query? Okay. So this is also very important topic for discussion, the perforation damage zone. So all of you have studied so much about the damage zone due to drilling and production or injection activities. So this is a zone and you will get the less permeability, that is KD you can denote, and this is undamaged permeability K, or you can say is uh, permeability of reservoir for undamaged zone. This is casing, this is cement, and this is open perforation. So when you create the perforation, here the charge and core debris will be present at the end of the perforation, and here In the surrounding the perforation, you will get pulverization zone, means it will have very fine particles, and this is a grain fracturing zone. So in this zone, whatever the grains are present, they will also get fractured. And this is a compacted zone. This zone will be compacted due to the very high pressure of this jet. Here the permeability is known as Kc, the permeability of compacted zone Kc, with damaged permeability from perforating. And you also know that the effectiveness of the communication path through the cement and casing is very critical to the completion and the well performance. Is whatever the path that we are developing, it will remain intact throughout the life of the well. And these perforation should increase the productivity by many ways. Like we can sometimes we can go for stimulation, then also we'll use these perforations, maybe sand control, or for naturally or producing formations we produce from this perforation. So this perforation is going to affect the well performance in a many ways, and that is why it is very important to select the perforation. And another important part is how to reduce this damaged permeability. So that is what we are going to discuss in the next slide also. So the altered area is called the damaged zone, like crust and compacted zone. So this is a crust and compacted zone is known as damaged zone through perforation. And damaged zone, it consists of crust and compacted grains forming a layer approximately 0.25 to 0.5 inch around the perforation tunnel. And for BH charges, the layer can be up to 1 inch surrounding the perforation tunnel. And one more important thing, you can see that this layer is also not uniform throughout the perforation. The damage is more at the entrance of the perforation as compared to the end of the perforation. You can see that. I think we are running out of time. So I'm receiving the message that we are running out of time, and but still we have 5 or 7 minutes. So at least we can complete this portion. Let us see. So what I was explaining, this is not having the uniform thickness throughout the perforation. Means you can say that damage is more near at the entrance of perforation as compared to end of the perforation. And the permeability of this damaged zone, it can be 10 to 20 percentage of the surrounding formation. So it is assumed that the permeability of this zone will be 10 to 20 percentage of the surrounding formation. Now you can imagine that if the permeability is reduced by 1/10 or 1/5 of the actual permeability, it is going to affect the productivity of the well drastically actually. So it is very important to design the perforation event to minimize this effect on well performance. So many research is going on to reduce the formation, to reduce the perforation damage with the help of different shapes of uh, different shapes of uh, different shapes of liner and different types of chargers they are using. So this is also one of the research area that you can consider, but for us it is practically not possible to do R&D on this area because we will not be able to get easily all the charges as well as the experiments that is required. They are very difficult and practically not possible in the school. But we have to consider this as an important aspect when you select the perforator. We have to reduce this damage as minimum, means reduce the damage means the damage should be minimum as possible. Okay, my voice is not coming clear. Okay, I will try to improve. I think I am a little bit exhausted because I already took one lecture for class B and now I am taking your lecture. Sorry for it. But do you have any query in perforation damage zone? Should I repeat? And sometimes what happens, if your internet is not also good, then you will find some disturbance. So that also may be the problem. And if my internet is also not good, you'll not get good quality sound. Okay, let's go ahead. So natural completion perforating. So all of you know that natural perforation completing means it can be defined as those wells with sufficient reservoir permeability and formation competence to produce economical hydrocarbon rates without stimulation. So when the reservoir has certain energy that without help of hydrofracturing treatment or any other stimulation treatments it can produce. So in that kind of formations, if we complete, then it is known as natural completion perforating. I hope it is very clear. So the important perforating parameters include perforator depth of penetration, charge phasing, effective shot density, percentage of the productive interval that is perforated. So these are the important parameters which will affect the performance of well. And but if the diameter is generally more than 0.25 inch, then it is of not much important. And as we discussed in the previous slide, it is important to decide the depth of penetration, and for that we can use the open hole resistivity logs and data from that to find out the what is the radius of invasion, because we have to select the depth of penetration should be more than that, because here we are not going to hydrofracturing the formation. So whatever you are able to develop the perforation, from that only you are going to produce. So if your perforation depth of penetration is less than the radius of invasion, and you will not be able to bypass the damage zone, so the permeability of near wellbore area will be very less. So that is why it is important to evaluate the radius of invasion and from that select the depth of penetration. And it is also important to select the phasing of perforating gun, because at different directions are desirable, because if it is having the different phases, then there are chances of contacting the natural fractures. And the commonly used guns have different phasing like 45 degree, 60 degree, 90 degree, 120 degree and 180 degree, which are commonly used. And effective shot density is also an important perforating parameter, not only to increase the number of flow paths to the wellbore, but also to contact thinly laminated hydrocarbon layers. But if you are having the very highly permeable, one second, let me, but if you are having the very highly permeable formations, then obviously it is desirable that we should have higher shot density. Higher shot density means higher number of perforations per foot. So you can have a higher production rate. So generally 4 SPF will always provide comparable inflow performance, but generally this is a thumb rule which may not be accurate or correct for all the formations. So from the experience, you can find out that what kind of number of perforations are more suitable for particular formations. And high shot densities are important in gravel packed wells. When it is a natural compression perforating with gravel packing, you know that gravel packing is used for sand control. So in that case, we have to use higher shot densities. So you can understand that it is very important as a completion engineer to realize that perforating systems are mechanically very complex, and and one more thing is important, all the perforations that we are creating, they will not be effective in producing the hydrocarbon. And according to the case studies and studies in the laboratories, they suggested that only 50 to 70 percentage of the perforations are actually effective. So this also you have to consider. So you have to create the perforations little bit more, because you have to assume that around 50 to 70 percentage will only contribute for the production. And I think there is one query from Dharti Patel. I am keeping her online. One sec. Dharti, you are online. You can ask question. Please go ahead.
Sir, how does the radius of investigation affect the depth of penetration? Also, radius of investigation has some permeability. So how does permeability also affect the depth of penetration? Because depth of penetration should be actually affected by the compressibility of the compressive strength of the rock.
I agree with you. It depends on the compressive strength of rock. But suppose here we are talking about the natural completion perforating. Means you can assume that it is a cast and perforated well completion, and in future we are not going for any hydrofracturing treatment. And in that case, due to the drilling, you have damaged the formation, and you are perforating in the formation, and you are not able to bypass this zone, damage zone during drilling. So you know that skin factor, you will have very high positive skin, and your production rate will be quite low. So in that case, it is
Yes.
always desirable to have depth of penetration higher than this radius of invasion. Means you should be able to bypass this damage zone. That's what it means. Is it clear?
Yeah.
And for that, you have to use these resistivity logs to find out the radius of invasion.
Okay.
I hope it is clear to everyone.